Hi Pre-Calc. Today we're going to work on applications involving exponentials and logs. So let me start with this one because I want to do one with you that's similar to your homework. You're going to have this section here, so I want to, one of the things you're going to have is that section there. So I want to work on something similar to that. So let's take a look at what they're telling us. They say that we make an initial investment of $750. We have an annual percent rate of 10.5%, which is extraordinarily high, but we'll take it. And time to double is what we need to find, an amount of after 10 years. Okay, so let's see here. Time to double, amount after 10 years. All right, so do they say, oh, okay, so I had to, this was the part we had to catch, which I didn't write. Assuming continuously compounded. All right, when they say that, anytime they say continuously compounded, okay, those are the key words that you're using this formula. Okay, those are the key words that you're using this formula. So let's see what parts they're giving you. Oh, you know what? I wrote it in the generic form. Let me write it in the money version. Most of you will recognize it more in the money version. These are actually the same equations. It's just for the money we tend to recognize the A and the P. But if you do it like this and you get it like this, it's absolutely fine. Okay, so the money we put in, so they're basically saying that P is 750. Oh, this would be RT in the money version. Okay, in the money version, so then annual percent rate is 0.105T. So also let me remind you that you need to convert your percents. You need to convert your percents to decimals. So that's moving the decimal 2 units to the left. And okay, those are the parts that we're given. Now for the time to double, if they start with $750, then what would that be if you double that, right? That's going to end up being $1,500. So for the first part here, we're going to make this $1,500. And we're going to solve for T. Now remember, whenever you solve an exponential equation, you have to isolate it first. So you're going to have to divide off the 750. Alright, and this is base E, so we can take the natural log to both sides. Alright, if we use our logarithmic properties, we can bring the exponent down in front. So we'll bring this down in front. Right, and again, ln of E is equal to 1. We've solved that a few times. Let me move this over here. Alright, now you just have to isolate the T. So you're going to divide off the 0.105 to both sides. Right, and now you're ready to find the time. So just be careful how you put this in your calculator, because the logarithm will take everything that you put in there if you don't close the parentheses. So this is a very common error. So I'm going to do ln of 2. Now notice when I do this, I'm going to close the 2. If you don't close it in your calculator, it's going to take everything after it, and you're going to get a different answer. So you just want to take the logarithm of the 2, and then you want to divide it by 0.105. Okay, it's going to give you a totally different answer if you don't close the logarithm. All right, let's just do this to 1 decimal. So let's say 6.6, and time in these problems is always in years. So the final answer here is going to be 6.6 years. All right, so that's the first part. All right, amount after 10 years. Okay, amount after 10 years. Let me get a new sheet for that. So we have A equals to 750 e to the 0.105t. Now, by the way, when you're creating your model, the p-value doesn't change. That's consistent for all applications of the model. The r value will not change as well. Those are fixed values, just like if you had a linear equation, a y equals mx plus b. If you had a linear equation, just like your slope and your y-intercept is fixed, x and y change, but m and b stay constant. It's the same thing when you make a money model. The amount invested and the percent rate is fixed. It will stay the same for whatever applications you do. All right, so here's the next thing we want to know from our model. We want to know the amount we would get out after 10 years. So in this case, they want us to let t be 10 and figure out what a will be. Now, that number is so nice and easy. Let's just go ahead and multiply this. So this is just going to move the decimal over one spot. Right? If you multiply by 10, it will move the decimal 1 unit to the right. And now let's put this in our calculator. Your calculator should do this from left to right with no problem. So we're going to have 750. Let me make sure you can see that. Okay, 750 times. Now you have to get the E key. For me, it's right here. You have to find it on your calculator. To the 1.05. I just would get in the habit of closing it. It'll give you the right answer if you don't close it, but sometimes you need to close the function, and if you just get in the habit of closing it all the time, you'll never run into a problem. Okay, so let's see what we've got here. This is money, so you don't want to go past the penny. It won't make any sense. So either on the test you can round to the dollar, or you can round to the penny. I'm good with both. I'll just round this to the penny with you guys for 3.24. Okay, $2,143.24. Okay, gang, I'll end that here on this video, and we'll pick up. We are going to do more money. We're also going to do carbon decay, which is an interesting concept. All right, catch you again in another video. Bye-bye.